everybody. How are you guys doing? Welcome, welcome. It's kind of a stormy day outside. Good afternoon, everybody. Stormy Thursday, right? Hope you guys are doing well. Today we are going to be reviewing for the final, right? So your final is Tuesday, June 1st. So I do want to start class just by saying I do know there is a lot going on this afternoon. So I'm going to structure class like this. Um, so again, because there is a lot going on this afternoon, what I'm going to do is I'm going to highlight all of the topics that we have covered since our midterm that are going to be on our final. And I'll go through and just highlight everything that can be on the final. And then what I'm really going to do is I'm just going to open it up and let people work at their own pace. So I know that tomorrow is a work day to get stuff done on the review for the final. But I also know that some of you guys are going to be struggling a little bit because you don't remember certain topics that we went over. So to kind of, I guess what I'm trying to say to bring this all together, because there's so much going on right now in this afternoon for some of you, and because we have our final on Tuesday, and we don't have school on Monday. So what I'm going to do is I'm going to quickly just go over everything that can be on the final, and then what I'm going to do is I'm just going to let it be open for a work day so people can get started on the review for their final. So that tomorrow, because there's no, again, I have to keep saying this, there's no school Monday. So I'm going to let people get started on the review so that tomorrow maybe there can be some more questions and I can do some more like targeted lessons and recaps and stuff. Yeah, trimesters are hecka fast, aren't they? Hecka fast. Okay, so, and I think by doing this, what it's going to do, it's going to allow, I know some people have things they want to do in just a little bit. So it's going to allow people to do that. It's going to allow people to get started. So I'm gonna treat you guys like young adults, and I'm going to trust that you guys are going to make the decision that you think is best for you. Okay? Does that sound good? Is there any questions about what's happening over the next few days? Again, our final is on Tuesday. There is no school on Monday, yeah, I will have office hours Tuesday morning though. So I will have office hours Tuesday morning. Does anybody have any questions about the schedule or about what we're doing today? I'm also recording this lesson and it will be posted to YouTube. So you need to do the review before the final. So the final is Tuesday. So that's why I'm going to let you guys start on it today. And I'm going to let you guys work on it tomorrow as well, because it is a bit longer than a normal assignment. So that's why I'm giving people time to do that. Okay. But first, what I want to do before we get into that is I want to go over what's going to be on the final and make a list of that for you guys. And then that way you guys can kind of plan out and be like, okay, I need to make sure to cover these things. Does anybody have any other questions before we get going? Or any concerns or anything like that of that nature? Okay, so let's go through. Let's take a look at what is and is not going to be on the final. And yeah, if you guys have questions, please go ahead and ask. I'm here to support you guys. All right, so I'm just kind of going to go through everything. So we started with 6.3, and this was about vectors. Okay, so with vectors, there's a couple of things you need to know. You need to know component form. Right, so an example of component form was like we had vector v, right, where it was like v sub x, v sub y. Okay, so that's component form. You need to know component form. You need to know magnitude. Okay, so that's the magnitude of a vector, right? And that's going to be of your delta x squared plus your delta y squared. Okay. Which, if it's at 0, 0, will be just vx squared, vy squared, right? So I think all of ours in this class have been at 0, 0, right? They don't always have to be at 0, 0, but in this class they all have been at 0, 0, I feel like, almost. So that's why I put the delta x, delta y, not the v sub x, v sub y. Okay. And then there should be direction. Right, so remember the direction angle is always, we define it as being with the x-axis. So the direction angle, I guess there's a couple of things I should point here, right? So we always start at 0. So we always start 0 to the right on the unit circle. And we always go counterclockwise. Okay, so that's just to remind you guys to do that, right? So for the direction angle, remember we always start 0 to the right, right? So what I mean by that is this is 0, this is pi over 2, pi, 3 pi over 2, 2 pi. Okay. Okay, and then we also did arithmetic. Of vectors. So with the arithmetic, right, we did adding, subtracting, multiplying. Dividing doesn't usually make a lot of sense because we usually do unit vectors. We didn't have time really to go over that this year, but that's basically you define your vector to be 1 unit long and then you multiply it. So just remember, right, if you have v vector and that's v sub x, v sub y, and then you have u vector, so that's u sub x, u sub y. If you add those together, right, that's going to be v sub x plus u sub x, and then v sub y plus u sub y. Okay, so you're just adding like things, and that should be, you guys should be familiar with that from doing like polynomials, right? Polynomials, right? You always combine things that look like. Okay, some other stuff, right? We're still in 6.3, so you need to know I and, oops, sorry, that's I, I and J format. So you need to know I and J format. So usually I and J format goes with the trig format. Okay. So for example, if you have vector W, you could write that as 6i minus 7j. Okay, so it's basically like component form, right? You have your x and your y term. The only difference is that this is going to be more useful when we get to trigonometric complex numbers, right? Where we add in the trig and the sine and the angle, right? Because component form and ij form are very just simplistic vectors, right? And we start getting angles and more complex directions. That's when we're going to use trig. Okay. Okay, and then we also did word problems here. Okay, where we had multiple vectors. multiple vectors and find the resultant. Okay, so find the result. That's an L. So find a resultant vector. Okay, so this is where you add vectors tip to tail, right? Like so if this is V, this is U, this is your resultant. So do you guys remember doing that, right? Your resultant vector, so adding multiple vectors and getting a resultant. So this happens in physics quite a bit, right? With free body diagrams, you have multiple force vectors happening on an object, and the resultant is what's the net acceleration if there is any acceleration. Sorry, I just realized maybe I'm going a little too fast, so I'm just taking a little breaks to make sure people can write stuff down. Okay. So that was basically all 6.3. Sorry, I got to move a deck of cards I got here. All right. So 6.5. Was about the trig form. Okay, so with trig form, a couple of things you need to remember is the modulus. You need to know about the complex numbers or the complex plane. You need to know the absolute value of a complex number. Okay. And remember with trig form, right? It's going to be like you have the magnitude times cosine of theta I plus sine of theta j, like that. So you got trig form right there. And I'm just going through, guys, and I'm just making a list, right? I'm just making a list of things we covered. So these are all the things, again, that can be on the final. So when you go to study, you want to go through this list and be like, hey, do I know what this is? Can I solve a problem that has stuff in this? Can I identify it? Stuff like that, right? So this is just like a checkoff list. Okay. 6.6 was trig form of complex numbers. Okay. So the only difference here is that one of your numbers is imaginary, right? So an example of this would be, again, you have your magnitude times cosine of theta plus sine of theta I, which is confusing with IJ formation, okay? Right? Because this is different because it's on a different plane. right? So this j and this I are a real plane. Okay, whereas this is on an imaginary plane. Okay. How are we doing so far, guys? Am I going at an okay pace? Does anybody have any questions? And then, so what would you do with trig form, right? Like, you'd solve word problems, you would do math with them, you'd combine them, you would multiply them, you'd find magnitude, you'd find direction, right? So given a vector, like, you know, right? You guys remember doing all that stuff? Okay. And the review has really good questions on it. So I really do think the review for the final is a really good review. So you're definitely going to want to do that. Like, the questions on there are going to help you guys out with the final immensely. Okay. And then we changed directions. So then we had 10.2. 10.2 was, so we're in conics, right? So we're conic. So the first one we did was parabola. I'm really glad that you're back in. Yeah. Dude, I hate when the internet does that. It's like the suckiest thing ever. Super. And remember, all of this is on YouTube, so you missed a bit. So you're going to want to go back and watch the start of class on YouTube. All right, so parabolas. Okay, so there's a lot of things with parabolas that you guys need to know. You need to know, like, so the thing is that it's an open note test. So all the equations or all the formulas. Okay. And I'm just now, normally, like, I would go over like tricks to memorize them and like how to do that, but you guys don't need to memorize any of that, right? So it's all in your notes. So I'm just going to say all the formulas, right? What are some key features that you need to know, right? You need to know the directrix. You need to know the focus. You need to know the vertex. You need to know A, B, and C. Okay, so directrix, focus, vertex. Yeah. Okay. Okay, and then I would just say vertical and horizontal. Okay. And then I don't really remember. I don't think we did completing the square in parabolas, but I'm going to throw it in here because I think we had to complete the square in all of them. And what I mean by complete the square, right, I mean going from a polynomial to what the book calls standard form, which I've always just known as conic form or geometric form. Okay. So, right, a polynomial, right, is ax squared plus by squared plus cx plus dy plus e, like that. That's polynomial form. So be careful with A. So in polynomial form, it's just alphabetical order. It's in descending order. So see how it just goes A, B, C, D, E, right? If you're talking about a in a parabola, that goes with the direction that it's opening up. If you're talking about an ellipse, right, then A goes with the part of the ellipse that's longer, right? So if it's longer in the x, it goes with the x. If it's longer in the y, it goes in the y. And then in a hyperbola, a is always in the front, right? So if you're opening up left to right, then x is over a. And if you're opening up and down, then y is over a. But in a hyperbola, the a is always in the front. Okay, so it's slightly different, right, for each one. It's just different enough that you need to know them a little bit. Okay. So, right, so just because a is in the front doesn't mean it's the biggest number for the hyperbola. Okay. And then we did 10.3, which is conic. We did the ellipse. That's what we did, didn't we? Did we spend 2 days on the ellipse? I can't remember. Okay. Sorry, I'm just checking my notes here. I'm right. All my teaching notes. I'm just looking at my notes and things that needs to be on here. So, so with the ellipse, you need to know all the formulas. Right. Again, these are in your notes. Okay. So with the ellipse, the big thing here, right, is the major versus minor axes. Right, so major is A, B is this, right? C, right? C is still distance to the focus, but you don't have a directrix, right? There's no directrix here. Okay, and then vertices are along major axes. What else do we need to know? Oh, and you have to be able to complete the square. Right, and to go from polynomial to geometric. Okay. And then one last thing that I should throw in here, eccentricity. Eccentricity, I don't know what I just said. Eccentricity, right? That just tells you how close to a circle you are. That's E equals C over A. Right, and that kind of makes sense because C is the distance from the center to the foci. Oh, I should say foci here. So the distance from the center to the foci, and A is the length, right? So if the distance is 0, right? If E is 0, that means you have a circle. And if E is 1, that's basically, it's a scale from 0 to 1. If E is 1, then that means, right, then C and A are the same. That means you have a straight vertical line. So it's either, the closer you are to 0, you have a circle. The closer you are to 1, you have a vertical line. Or a line, sorry, it would be a horizontal line. Okay. So that's that. Am I going too fast? Is this okay? Then we did 10.4. We did conics. It was a hyperbola. Okay. So with a hyperbola, again, all the formulas. So don't forget to include, right? It's the equation, don't forget asymptotes. Okay, and that's it. That's everything that's going to be on the final. And I did. I made it to 130. Whoop, whoop, whoop. All right. That was my goal. because I know some of you guys have things going on. At least that's what the word on the street is that there's something going on at 1:30. So what I'm going to do is I'm going to open up the rest of this time to be a work time. So whether that is you guys are asking questions or you're just working on the review, I'm going to give you guys from now. So it's 1.5 classes to work on the review and ask questions. Okay. I also have office hours tomorrow morning before school, and I have office hours before Tuesday, right? The day of our final, and everyone's taking the final. Right, and then so there's two more office hours before our final. Okay, does anybody have questions about that or anything I can do to help or anything like that?